Good morning, everyone. We have come to the last module of Unit 4. Today, we will be looking into what do you mean by ANOVA, okay, and multidimensional scaling. What is it? In last module, we had seen what do you mean by parametric and non-parametric test, and we had seen three different tests which comes under parametric test. One is Z test, the other one T test. Then we had chi-square test. So ANOVA is something which is again a parametric test. We assume that the population is normally distributed, and the full form of ANOVA is analysis of variance. This was proposed by Fisher in 1920. Okay, so basically it is when there is one population, and in that population there are large subgroups which we are comparing, or else we are comparing two different population which is having a normal distribution. So that is where ANOVA comes in ANOVA. If you check, one factor cannot be able to be written in terms of factors. We can't measure one of the variables. In such cases, we can't put quantitative measures to that. In such cases, we will be using ANOVA. So let's see what it is. So analysis of variance is an analysis tool used in statistics that splits the aggregate variability found inside a data into two parts. One is systematic factor and the other one is random factor. Systematic factor have a statistical influence on the data, while random factors do not. Okay, and analysts use the analysis of variance or ANOVA to determine the results that independent variables have on dependent variable amid a regression study. So basically it is when the population is huge and it is getting divided into subgroups. There are certain assumptions which we will be looking into ANOVA. First one is the parent population is normal, and the error component is distributed normally with zero mean and constant variance. And the last one is various effects are additive in nature. So if we break down analysis of variance, the analysis of variance test is initial step in the factors that affect a given data set. Okay, it is something similar to F test, which we have not covered. Okay, and it is this type of ANOVA test depends on number of factors. Okay, there are different types of ANOVA, and the type of ANOVA which we will be looking on will be based on the different factors. It is applied when data needs to be experimental. So based on if it is an experiment one, you have to have so many different factors which will be influencing. One is systematic factor and the one is random factor. In such cases we will be using ANOVA. It is similar to multiple two sample t-test. So the different types of ANOVA we will be looking in the next slide. Okay. So let's see what it is. So basically, it was told by or it was developed by R.E. Fisher in 1920. It is used for comparison of more than two population or population having more than two subgroups. We will be using the ANOVA. To simplify the assumptions which were told in the previous slide, let's see it in a much simplified manner. Each group sample is drawn from a normally distributed population, and the population have a common variance. Okay, the variance means the square of your standard deviation. So all sample, and what do you mean by standard deviation? How much how much spread it is in you when you draw in your graph. You would have studied what is standard deviation in your second semester. So that is so all population have common variance and all samples are drawn independently of each other. That means if one occurs, the other won't occur. Within each sample, the observations are sampled randomly and independently of each other, and the factors effects are additive in nature. ANOVA is something similar to regression, but in this one, we are looking into the variance, difference in variance. We are not looking into the correlation. And there are three different types of ANOVA. First one is called one-way ANOVA. In this one, we are considering only one sole factor. Okay, and in two-way ANOVA we are comparing one dependent variable with two independent variables. For example, if we are comparing the workers productivity based on two different independent variables, it is called as two-way ANOVA. For example, workers productivity based on motivation and love for work. In that case, work productivity we are comparing only with two different independent variables. That in that case we will be using two-way ANOVA. And if you have checked, if workers productivity is not something which you can quantify, so in such cases we will be using ANOVA. The multi-factor ANOVA means when more than one factor is present and the factors are crossed, that we are comparing the main effects and interaction of these factors, then we will tell it is a multi-factor ANOVA. And there is, if you are looking into the variance component analysis, then we have something called multivariate analysis of variance, that is called MANOVA. It assess the relationship between two or more continuous dependent variable and other variables, categorical variables or factors. So this is about ANOVA. So let's just brush up what it is. It was developed by R.A. Fisher in 1920. It is compared when two population or one population with large subgroups are getting compared. In this one, we assume that the population, the distribution of population will be of normal distribution, and all population have a common variance. All samples are drawn independently of each other, and within each sample, the observations are sampled randomly and independently of each other. And the factors which contribute to this independent factors is of additive in nature. So these are the factors. There are three types of ANOVA: one-way, two-way, and multi-way ANOVA. And if you are taking into variance into consideration, there is one called as multivariant analysis of variance, which is called as MANOVA. If you need anything detailed or basics of ANOVA, I think this YouTube link will be very helpful for you. So please go through this. For exam purpose, we have to know what is ANOVA. So let me just tell what are the different things. There are four parametric tests which we have learned till now: t-test, z-test, chi-square test, and ANOVA. ANOVA is something which is a parametric test because we assume that the population is normally distributed, and when we use this when we are comparing subgroups, large subgroups within a population, or you are comparing with two populations. Okay, now you have already learned what do you mean by regression. Let's see what is the difference between ANOVA and regression. Okay, in case of ANOVA, the purpose is to determine whether the means of two or more populations are statistically same. In regression, we are more focused on cause and effect. That is, you are predicting y based on the value of x. Okay, and type of question is there a statistical significant difference between drug A, B, or C? And if it is, example in regression is how much do house prices increase the number of as the number of bedrooms increases. So this is between two variables. If you are predicting, it will be regression. If you are predicting about the population or effect of something on different population, it will be ANOVA. Then the variables which we will be using is, one will be categorical. For example, in this one, what is the impact of A and B on somebody is categorical. So one will be numerical and the other one is categorical. In regression, both the thing will be quantitative or it will be numerics. And if you're checking into your ANOVA, you will be looking into individual populations or big sample subgroups in a large population. And in regression, we will be checking into the values of y variable versus corresponding y values on a regression line. Focuses on variation, yes, in both cases you are looking into the variations. Then if you these points not much important for you. Okay, yes, variation of means of different population is getting compared here. Variation of dependent variable based on independent variable is considered. And this it is primarily used in case of designed experiments, and regression is mainly used for inferential statistics, but validated via designed experiments. Like inference, if you have to make some inference, we will be using regression. If you want, and in case of ANOVA, how people perceive about something in different atmospheres, we will be using ANOVA, wherein we are not able to directly measure one of the variables or two of the variables which we are taking in quantity terms. We will be using ANOVA. So this is the difference between ANOVA and regression. And coming to the last point of this chapter, multidimensional scaling. Multidimensional scaling creates a special description of the respondent's perception about a product, service, or other object of interest on a perceptual map. This often helps the researcher to understand difficult to measure constructs such as product quality or desirability. When we have to compare something which cannot be quantified, which can be only like product quality and desirability is something which cannot be quantified, it is based on certain different parameters. In such cases, we will be using multidimensional scaling. It is a non-parametric test or non-parametric way of doing things. In this one, we will be first formulating the problem, then we will be taking different inputs based on different factors, then we will be coming up with what procedure we are going to take, then we will see how many, like in this case high low is there, and two variables we have taken like prestigious to own and financial effectiveness. So based on these two factors we are comparing, so number of dimensions we will be taking into and label the dimensions like prestigious to own and financial effectiveness, and the last one we will be checking the reliability and validity. So in this case how we are thinking is like how each one of them perceive in terms of the price of the car, as well as based on the prestige which is associated with that particular brand. For example, if you check the prestige thing, Jaguar is one with which is showing high, almost similar to Mercedes Benz prestige value. At the same time, the financial effectiveness is low. So based on this, we are able to compare things, and we are able to predict how the product is perceived, or desirability of a particular product can be represented using different methods, like in case of prestige and your financial effectiveness, how each brand is getting perceived by the consumer or the customer or the person who prospects is being getting charted down in this particular multidimensional scaling method. So this is a non-parametric test where we will be looking into the various parameters which will be influencing us in different. This is mainly used when it comes to perception or something which is related to your behavior. Multidimensional scaling will be one of the techniques which will be very helpful. So with this, we have come to the end of the unit 4. So let's just see what are the things which we learned till now. So in the first, we had seen what do you mean by data analysis? What are the steps involved in data analysis? What are the different types of tabulation? Then paths, yes. Okay, and then we came across what you mean by analysis of data, the purpose, goals, and type of analysis which we have. Then we had something called what is hypothesis, what are the definitions, the nature of hypothesis, characteristics. Then we had different types of hypothesis which are their steps in hypothesis testing. After that we came across what is type 1 error, what is type 2 error, what are the different tests like z test, t test, chi-square test, and in today's session we learned about ANOVA and multidimensional scaling. With this we come to an end of unit 4. Thank you. Hope it was informative and you understood. Please go through the module and the notes. So if you need any clarification on this, please feel free to contact. So thank